Think about the evolution of aviation. The changes didn't happen overnight. Engineers developed countless designs that were refined throughout the years. Design innovations have gone through the engineering design process, which consists of a series of steps that take place in a particular order to solve a problem. The stages of the engineering design process will be presented in this video through an activity that focuses on design and test of a very specific aerospace structural component, the wing. Basically, conceptual design is the very first stage of the project design process. It serves to provide a description of the proposed project in terms of a set of integrated ideas and concepts about what it should do, behave, and look like in a way that is understandable for users. Thus, in the first step, we had to consider several elements including bending and torsion. As a reminder, bending characterizes the behavior of a slender structural element subjected to an external load applied perpendicularly to longitudinal axis of the element. Torsion is the twisting of an object due to an applied torque. And then we have the preliminary design. The preliminary design often fills the gap between design conception and detailed design. Thus, in this task, the overall configuration of the system is defined and the schematics, diagram, and layouts of the project can provide an initial configuration of the project. For this step, we used a spreadsheet through Excel that allowed us to try several options. The goal is to achieve a set of performance requirements while minimizing different costs, such as the weight.
After using an Excel model that allowed us to calculate root tensile stress, root shear stress, torsion angle, and the final mass of the spar with different possible input sizes, we used the optimal sizes found using this model to build a CAD model of the final parts. The CAD model was then converted into a DXF file, which was then laser cut and ready for assembly. The resulting parts were then assembled using adhesive and covered in solar film to form a wing ready for testing. The Excel model predicted the wing would fail at a load of 6.02 Nm, whereas the actual wing failed at 6.867 Nm.
The wing load test was conducted using a series of 100-gram mass weights successively added to the wingtip. Wing deflection was measured using a ruler placed perpendicular to the wing edge and a phone camera. The ruler was securely held by clamps to prevent it from falling out of place. Weights were successively added to the wingtip until wing failure.